G'day guys, it's Paul from Polyman Astro, and in today's video I'm going to show you how I've streamlined my narrowband imaging processing using the RC Astro tools, and of course my new script 4X Palette utility. And if you stick around to the end, I'm going to give you a demonstration of just how powerful these tools can be on your processing and on your images. So the data we're going to look at today is some of the best I've collected to date on NGC 3576, the Statue of Liberty Nebula, which you can see here on her side. My wide field refractor's got enough field of view that it also includes NGC 3572 here, which is fairly rarely imaged, probably because it's so close to the statue, and both of them together are really close to the much bigger and more prominent Eta Carina Nebula. NGC 3572, I cropped in on this area a few years ago and did some processing and won an AA pod for that, so I was pretty happy with that. Probably because it's so rarely imaged and they just wanted to showcase it. But we're going to crop in on the statue and then rotate it so that it looks the right orientation. So I've already set up a crop of that. Actually, I'll show you what it looks like. So that's going to be the crop, about 50% of the frame, and then we'll rotate the right orientation. I deliberately set up the orientation this way so that NGC 3572 was in the frame as well, if you're wondering. But it just means that I have to do some cropping and rotation to get the statue the way we want her. So there we go, and now we can fill the frame with those. So there's my HA03 and S2 data. Cropped, and then we're going to do a dynamic background extraction. So I've already set this up so that it doesn't take 20 minutes for the video, and I've gone through and put sample points where I think there is true sky background and have a tight tolerance and smoothing factor, and then I tested that correction with subtraction to see the background model made sense, and now that I know that makes sense, I'm going to discard the background model and replace the image. Okay, and then I'll run this for each of them. And in case you don't know why I'm closing it and reopening it, it was run on, well, when I set it up, it was on the HA. So if I just drag it onto the image, then it'll use the HA data points that were there. So if I reopen the image, then it puts the samples in the right spot, but then it resamples them for the correct image. So that's rather important. So there we go. We've done our basics. We're now ready to run Blur Exterminator, Star Exterminator, and Noise Exterminator. So I'm going to open them up. Blur Exterminator, Noise Exterminator, and Star Exterminator. Okay, now Blur Exterminator I have set up with Auto PSF because I've got enough stars in the frames where that's going to be sufficient. If you're at a longer focal length or you're imaging, say, away from the galactic plane where there aren't so many stars, then you may need to run a PSF on that using, say, PSF image to see what scale you need to put in here and then put that in manually. And you'll notice that my non-stellar sharpening's been dropped quite significantly from the default down to 0.5. Sometimes even I need to go down to, say, 0.4. The reason being, if you push it too hard, then in the brighter regions, it tends to start connecting the dots and forming these worm-like structures that just, they're not real. And that's not a Blur Exterminator thing. I know there's controversy about Blur Exterminator making up data, but that's not what's happening. It's a deconvolution algorithm thing. And it happens when you push it too hard. So you want to be subtle. You want to do enough to improve on your PSF, and that's about it. The fact that it appears to do a little bit of sharpening as well is just a bonus. You don't want to push it too far. Noise Exterminator, I run a bit lower than the default. For this data, I'm going to run it about 0.7. Sometimes I can push it down even lower than that, but I think 0.7 works quite nice for this data. And Star Exterminator, I'm going to generate star image and unscreen the stars, and we can screen them back later. Now, the reason I'm showing you this is because I've set up CUDA now on my system, and it runs blazingly fast, but the video software that I use to record these videos also runs on the GPU and encodes things on the fly, and the two of them together kind of struggle. So I'm going to stop the recording, run these three things, and then I'll show you in the process console how fast they are. For context, Blur Exterminator used to take about a minute per image. Noise Exterminator was always pretty fast, and Star Exterminator used to take about 3 or 4 minutes per image. So if I look at the process console now and scroll up a bit, here's BlurX. So the initial AI took about 25 seconds for the HA, and then once the AI had done its thing, it was much quicker, about 7 or 8 seconds. Noise Exterminator, like I said, is always pretty quick, about 2 or 3 seconds. Star Exterminator now, though, is less than 20 seconds. Used to take 3 or 4 minutes. So CUDA is extremely quick. Highly recommend updating it if you can. Let's close these down now. We don't need them. I might move the stars a bit further out of the way. So we're ready now to start our stretching. So now I can go to Generalized Hyperbolic Stretch. Now I'll click on the HA image, and what I like to do is keep the screen transfer function open at the moment, because what I want to do is find some faint dust, which might be this region down here, say. So that's a bit of fainter dust, and I've clicked on it because then I can send to SP, and that'll be the symmetry point where most of my stretching is going to happen. And then I zoom in a bit just to see where it sits on the histogram. So somewhere around the peak, just to the right of the peak, is a pretty good spot. And David and Mike, the guys that created this, that's where they tend to suggest you should start. I keep my local intensity fairly high, especially for this, because it's already got quite a bright core here, and I want to control that and not blow it out too much. Now I can turn my screen transfer function off and see the true stretch. So if I click on the preview, then I can drag this up and get it to a point where I think a good initial stretch is. So probably about there. I don't want to go too extreme. I want to keep the background nicely controlled. And then I'll click another faint bit of nebulosity, which this region in here is starting to pop. So let's try there maybe. And you can see that's to the right of the histogram. I don't want this stretch to be as intense, so I might drop it a little bit. That's looking pretty good now. Look what it was before. You can see this area is kind of starting to pop. I'm keeping an eye on the brighter regions, and the K values there, they're not saturating. And I can quickly look at the log view, and I've got a little bit of space before I start clipping, so that's good. Okay, and then maybe one more. See if we can start bringing this dust out. Again, I want to drop the intensity. I don't want it to be anywhere near as big a stretch as before. That's probably too much. How's that looking? Look at the log view. Or just making it before we're clipping. That's looking pretty good. Yep, confirm we're not blowing out the highlights. And the other thing I'm looking at in the log histogram is this fairly uniformly traveling downhill? There's a slight hump there, but I think we're okay with that. And we haven't clipped any data. It's right at the edge there. That's what we want. So that's a good stretch for HA, I think, for the moment. Okay, so I think we're now at the point where they're ready to be combined. We need to stretch the stars now. Okay, so get rid of the screen transfer function on these stars because we don't need it. And what I'm going to do is work on the HA stars first. Shouldn't have closed GHS because I need it. Reset everything. And the way I work with the stars is I want a high intensity here to really protect and make sure I don't blow out the highlights. I don't worry about a symmetry point. I just run on a high local intensity and give a bit of a stretch. So if I look at the preview, I just stretch them until I think they look at a nice spot. So probably somewhere around there. And then I do the same exact stretch to the other two. And that's it. That's all I do with the stars. Nothing fancy. We're now ready to combine. So now's where my script comes in. So script utilities, 4-ax palette utility. Now, if you don't have this, then there is a short 2 to 3 minute video, which I'll link above and in the description to show you where to get this, either by the repository or the Google Drive. Repository is obviously the preferred option because then it'll update as I add updates. So I have 3 channels of data here, so I'm going to click on the 3 channel option, and I want to work on the stars, so I'm going to keep this unchecked. If I check it, then it grays out the stars here. This might be, if you've kept the stars in, then you just want to put your images in. You don't want to put separate stars in, or you do have separate stars, but you've run SPCC or something like that to get natural star colors, and you don't want to have any work done on those, and that's an option as well. So then you can only stretch the starless portions, the nebula portions. But I want to do both. So I'm going to select my S2, my HA, and my O3 image, and then the corresponding star images. And I'm going to click on execute. Okay, so I can minimize the dynamic expressions that the script creates. We'll look at the stars again later, but it's done some work on the stars. And we can close, actually we'll keep the HA open for the moment, but we can minimize down the S2 and the O3. So there's our 4-ax image at the moment, ready to go. Looking quite nice. Don't know if we need to do too much more work on that at the moment. So we can add the stars back to that image. And we'll do that by pixel math. So I'll reset the pixel math there. And because we unscreen them, we need to rescreen the stars. And this is the formula for rescreening stars. The $t again is the target image. So when I drag this, it'll be 4-ax. And the $t underscore stars matches, remember I'm dragging it onto 4-ax, so it's going to be 4-ax underscore stars. There's alternative expressions that are really the same as this expression. This is the one I just tend to think is the easiest to work with and easiest to remember. So I just drag that on and it adds those stars into the image. So I'll drag this triangle off because I'll use it again for the luminance shortly. Okay, so I'm going to make a copy of the HA. I'm going to duplicate it. So I can minimize HA now, and I'll call this Loom. And we're going to do some work on Loom. So I'll minimize 4-ax as well for the moment. We'll come back to that. So we're going to do some work on this luminance and just boost it a little bit if we can. So I need to create a mask. So I'm going to go to range selection. And I like to use the screening function with a little bit of fuzziness and a little bit of smoothness. And I just want to zero in on kind of just certain portions of the nebulosity. I don't want to sharpen everything. So kind of like that. Probably don't want to sharpen the brighter portions either. So we'll protect them a little bit. Okay. Now I'll clean this mask up a little bit because those top little bits I don't want. So I'm going to use clone stamp here. Might make a radius of 100. I'm just going to grey them out, black them out. So I don't need them. It's just the statue area itself that we want to kind of be working on, not the rest of this stuff. So I could probably even grey out, black out, sorry, most of this area. Probably don't need that bit. That bit. That'll do. Doesn't have to be perfect. So that's the range mask that we're about to apply to the luminance. Okay, I don't need to see it, so I'm going to click on this little button up here, and that shows and hides the mask. The mask is still applied, it just doesn't show it, so it's not in the way. And we're going to use LHE, Local Histogram Equalization. I like to start with quite a small kernel radius of about 20 for my imaging. And then I just apply it, because I found the preview doesn't quite give me the true story. And generally it's too much, especially if I zoom in on the actual statue, it's going to be too much. It's done a nice job, but it's too much. So I'll push it right down. I want it to be a subtle change. Maybe even a bit less. It's one of those things where you almost don't want to even notice it's done anything. So that's good. That's good. Now I boost it up to more like the 80 mark and run that. And notice again, I went back to 1. I always like to push it to the extreme so I can see it and then tone it down to taste. So the 80 is where it tends to do some quite dramatic things to the image, at least for my data. Might even go down to 0.35 there. And then I like to push it right up to 256 just to see. Sometimes this is way too much. Let's push this one right down. What's that look like on full? Yeah, I don't think we even need that one, to be honest. Okay. So let's remove that mask. And now we're going to do a quick bit of sharpening with MLT. So all processes, multi-scale linear transform. And I work on layer 2 and 3. And you use the bias layer, not the noise reduction layer. So I'm going to use a bias of about 0.1 on layer 2 and probably 0.0, maybe 0.05, 0.03. We'll see how we go on the third layer. And I've got a little preview set up here so that I can have a look. So let's run that and we'll zoom in a little bit and just see how that looks. I think that looks quite nice. It's done the job. So we'll run with that on the main image. And now we can add the stars back. And remember, we've got this little pixel math formula here that'll do that. The only problem is this was assuming that it'll have a target image with the name _stars. So we better grab these HA stars and duplicate them. And then I'm going to rename them as loom _stars. And put them down here with the rest of the stars. Okay, so now if I drag this across, it'll add those stars. And that's our luminance layer ready to go with the 4x image. So now we can use LRGB combination. turn off RGB, and the luminance is of course Lume. And let's see how that looks. It's looking quite nice. We just need to do a bit of saturation boosting, I think. Excuse the noise, that's my 7-month-old having a little bit of a play in the background. So let's boost the saturation. That's looking quite nice. Yeah, we don't want to go that far. Maybe about there. It's looking quite nice. And then we can have a quick look at the histogram just to see where we're at and if there's any room, any wiggle room, just to bring that down a little bit. Not really. I don't want to go too far. Maybe about there. Okay, and there we go. There is our image using my new, well, my streamlined techniques, not so new techniques, but streamlined techniques to produce a rather nice borax image. Okay, now we get to the second part of the video. So what I've done is I've taken a clone of this and popped it onto this screen over here. And what I'm going to do is I'm going to do a star alignment based on this little image down here called Statue A. I need to give it a bit of a helping hand because they are quite different in FOV, field of view. So I'm going to maybe push it out, maybe about there might be sufficient. And I'm going to run star alignment. There we go. So I'll minimize the clone. So we've cropped in quite a lot. And remember, originally, this was 50% of my original field of view. And now we've cropped in to less than half of this as well. So we're talking quite a small field of view from my original field of view. So this is quite a crop for my system. And we're going to compare it to this image here. Now we're not going to go like for like in terms of processing because they weren't processed exactly the same. And this one had much less editing done on it than the image we've just seen here. But we can see they compare fairly favorably. This one is obviously a lot sharper and seems to have potentially a little bit better contrast in some of the dust regions here, maybe not. But it's definitely much better resolved. And if you look carefully, you can see there's a little cross here. So perhaps that's starting to hint the kind of system this was taken on. Remember, this is a little 71mm refractor from my backyard under very poor seeing conditions, I'd say. Maybe poor, but I'd say verging on very poor, being so close to the coast. And we sit right under the jet stream for the most part here. But it's done a decent job of resolving, and with some of these new powerful tools, I think the result looks awesome. I love it. This is with a CD K24 in Chile. Some of the best skies in the world, one of the best telescopes in the world. The setup probably costs as much as my house. So the fact that this is resolving at a much finer level of detail than this one, not surprising, but the cost differences are astounding. So I think basically what I wanted you to get from this comparison was that your setup, no matter how expensive it is, how large the aperture is, what kind of skies you have, with some of these newer software techniques, you can produce quite an awesome looking image that compares quite favorably with something taken with something 10 times, maybe even 100 times the price of your setup under the world's most pristine skies. So I mean, doing this comparison, I'm very happy with the setup that I've got and what I can get out of it. Anyway, hopefully you agree. Thanks for watching.